Hey guys, welcome to question MM441 of the Maths Methods Fortify study guide. In this question we've got Vic Roads is looking through their data to determine what type of cars Victorians drive. The time it takes for a car in Victoria to reach 100 kilometers an hour is a continuous random variable x seconds given by this probability function. Part A, which is a 2-mark question, says 20% of the cars take less than k seconds to reach 100 kilometers an hour. What is the value of k correct to 2 decimal places? Awesome. So first of all, whenever we're dealing with this 20% of the cars, or 20% probability, what we're actually talking about is the area under the graph, okay? So we know that our area is going to be equal to 20%, which is 0.2 in terms of a decimal. So how do we find our area? Using our integrals, right? So the area from less than k, so 0 to k, of this function, which is 6 minus x take 20 over 324 dx. This is our function, right? So we're saying that the area between 0 and k, 6 and k, that should be, my bad, 6 and k, is our lower and upper, right? So our lower is 6, and we're trying to find from 0 to 6 to k. Now, we can simply just evaluate this now. So we get 0.2 equals, we can do this in our CAS, I actually would. We get negative x outside of x squared take 39x plus 360 over 972 from 6 to k. This is our first mark here. Continuing to evaluate this, we sub in our k value, we get negative k outside of k squared take 39k plus 360 over 972 minus negative 6 outside of 6 squared minus 39, 6 plus 360 over 972. Awesome. Sweet. So from here, just simplifying all this, we get negative k squared take 39k plus 360 over 972. All of this simplifies down to positive 1. Negative 2 equals that. We can take this 1 to the other side, so what we end up with is negative 0.8 equals this, and then simplifying all that, we get 777.6 equals k outside of k squared minus 39k plus 360. Awesome. Now, because we have our CAS available, I would simply just do this in my CAS. No point trying to do it by hand. And what we end up with is k equals 3.15, 9.32, and 26.5. But we can't have all of these as our answer, right? Because our domain is from 6 to 15. 9.32 is the only value of k which lies between that value, which means that k is equal to 9.32. This is our second and final mark for this part. As always, guys, let me know if you have any questions, but for now, let's move on to part B. Part B is a 2-mark question again, and it's a little bit different. We'll leave that there, actually. So part B, 2 marks. It says, if a car takes more than k seconds to reach 100 kilometers an hour, what is the probability that it takes less than k plus 3 seconds to reach 100 kilometers an hour? Awesome. So essentially what we're saying is we're looking for the probability that it takes less than k plus 3, so x is less than k plus 3, but we know that it takes more than k seconds, right? So given that, it takes more than k seconds. Awesome. Now, as we know, this is a given formula, so as per our given formula, we have x is less than k plus 3, intersect x is greater than k, over the probability that x is greater than k. Okay? Sweet. So we know that k is equal to 9.32, we found that in the previous question, which therefore means that k plus 3 is equal to 12.32, okay? So what we're actually looking for is the probability that x is less than 12.32, intersect x is more than 9.32, over the probability that x is greater than 9.32. Awesome. Now, we know that the probability that x is less than k is 20%, right? The question told us that, which means that the probability that x is greater than k equals 80%, or 0.8. So we immediately know that this is 0.8. Now we need to figure out this. So what we're saying is the x value is between 9.32 and 12.32, which means we're finding the area between 9.32 and 12.32 of 6 minus x, x minus 20 over 324 dx over our probability that x is greater than 9.32, which is 0.8. Awesome. This is our first mark. Simplifying this down, in our CAS, this top bit here becomes 0.4026. We've got over 0.8 there. You can show as much working there as you like. I've just kind of done it all in the CAS just for the sake of quickness. If you're not too sure about how to actually get there, just let me know and I'll shoot you an answer. Chucking this in your CAS, you get 0.5032, which is your second and final mark for this question, or for this part. Guys, if you have any questions about it, let me know. But for now, let's move on to part C. Part C is a 3-mark question, and here we're going into statistical inference. So we're just going to get rid of this. And it says, Vic Roads takes a survey of a number of registered vehicles. After this survey, they are 95% sure that more than 80% of cars reach 100 kilometers an hour in less than 12 seconds. How many cars were a part of this survey to achieve this level of confidence? Give your answer correct to the nearest whole number. Awesome. So what we're dealing with is a confidence level, right? So what they're saying is they are 95% sure, which means that they're a 95% confidence interval, right? Now, we know that the confidence interval is 95%, and we know that a confidence interval, where am I going to write this? Let's do it here. So a confidence interval is given by p hat minus z outside of the root p minus 1 minus p on n, p hat plus z, p hat 1 minus p over n. Awesome. We're trying to find how many cars are a part of this survey, which is this n value, right? So we need to sub in everything else in order to find out n, okay? So if we have a 95% confidence interval of that more than 80% of the cars reach 100 kilometers, that means that we're 95% certain that between 80% and 100% reach them in that time, okay? Which is equal to 0.8 to 1, right? Now, these two numbers correspond to these two formulas, right? This is our lower bound and this is our lower bound. This is our upper bound and this is our upper bound. So what we can say is that 0.8 is equal to our lower bound here, which is p hat minus z, p hat 1 minus p hat over n. Awesome. Also, this is our first mark down here. So now we can actually sub in values here. So we know that our p hat always lies halfway between our confidence interval, okay? So halfway between here is our p hat. Halfway between 0.8 and 1 is 0.9. So we get 0.9 here, minus our z value is determined by the level of confidence. So at a 95% confidence interval, that means that our z value is equal to 1.96. And this should just be knowledge that you have. If you don't have that knowledge, that's fine, you just keep practicing. P hat again is 0.9, outside of 1 minus 0.9 over n, and this is our second mark, because now we only have one variable n, and we can actually solve for this now. Moving all this around, we get 0.1 equals 1.96 outside of 0.9 times 0.1 over n, which means that we get 0.0510 equals this over n. 0.026 equals 0.09 over n. So therefore n is equal to 34.57, and we're asked for the n value closest to the nearest whole number, which means that our n is equal to 35. This is our third and final mark for part C, guys. I know it's a little tricky, but just try and get used to using these confidence intervals and the lower and upper bound to find your values. For now, let's move on to part D. Part D is a 3-mark question again, so let's just be a little hacky here and just add a D in there. The weight of any one of these cars in Victoria, y kilograms, is a normally distributed random variable with mean mu and standard deviation 200. Awesome. Now, I'm actually just going to get rid of this because we don't need this anymore. Just get rid of everything. Part D says if 60% of the cars in Victoria weigh more than 1350 kilograms, Find the value of mu correct to 2 decimal places. Awesome. So we know that it's normally distributed. We know that our mean is mu. And we know that the value that we're looking for is 1350 kilograms, right? So it's going to lie here. We know that 60% of the cars in Victoria, so 60% here, 60%, way more than that, okay? So what we're going to need to do first is find our Z value that corresponds with our 1350, right? And what I mean by that is finding the number of standard deviations away from the mean that this 1350 actually is. So the way that we do that is by using our little magical formula that links Z and X together, which means that we have Z equals X minus mu over standard deviation. So in this case, we're trying to find our, before we even do that, before we do this, what we need to do is find our Z value at this point, because we're not going to be able to link those two if we don't know the Z value. So what we're going to do is use our inverse normal. So we're using inverse normal because we know the probability and we're trying to find the Z value, okay? So inverse normal asks us for three things: area, mu, and standard deviation. So average and, mean and standard deviation. Now the area is always the area to the left of the point that you're looking at, okay? So we know that the area to the right of this is 60%, which means that the area to the left is 40%, right? Which means that our area is going to be 0.4. Now, we don't know what our mu is, so we can't use our X values here. What we're actually going to use is our standard normal distribution to find out how many standard deviations away from the mean we are. So mean equals 0 and standard deviation equals 1. Putting this into our CAS, we'll get an Z value of negative 0.2533. That's our first mark. So what this means is our value of 1350 is negative 0.2533 standard deviations away from the mean. So now we can actually use this formula because we can say that our Z is this. So we get negative 0.2533 equals X, which is 1350, minus mu. We don't know what mu is. We're trying to solve for that. So minus mu over standard deviation, which we know to be 200 because the question told us that. This is our second mark. Now we just need to solve for mu, right? Because mu is our only unknown. So we can actually just move all this around. What we get is mu equals 1400.67 kilograms. And that is correct to 2 decimal places, which is what the question's asking for. This is our third and final mark for part D, guys. And that's it. So let's move on to part E. Part E is a 2-mark question. And says, a sample of 200 cars is taken. Find the probability that p hat is less than or equal to 0.4. Now, what we're talking about with p hat, actually I'll just finish the question, where p hat is the random variable of a distribution of sample proportions of cars that weigh less than 1350 kilograms in samples of size 200. So, what we're saying is, we want the proportion of cars that weigh less than 1350 to be less than or equal to 0.4. So we know that proportion is equal to x over n, right? Where x is our number of cars that are less than 1350, and n is the total number of cars in the sample, right? So we know that our p hat is equal to 0.4. We don't know what our x is because we don't know how many of the cars are actually weighing less than 1350, but we know that there are 200 cars in the sample, so we can say that that's over 200. Rearranging this, we get x is equal to 80, okay? So the reason that we're doing this is because we want to create a binomial distribution for this probability function, I guess. Now, the reason that we do that is because we don't know how to evaluate this, right? But we do know how to evaluate binomial distribution. Because in this sample of 200 cars, a car can either be less than 1350 or more than 1350, and obviously like including 1350 itself. But there's only 2 outcomes there, which means that we can use binomial distribution. So that means that the probability that p hat is less than or equal to 0.4 is the same as the probability that x is less than or equal to 80. This is our first mark, okay? Now, from here, we can simply use our binomial CDF in our CAS. And that'll ask us for 4 things. It'll ask us for a lower, an upper, n, and p, okay? Now, lower is our lower bound for this probability. Now, we're talking about everything less than 80, which means that our lower is going to be 0, okay? Because we can't go lower than 0, so our lower is 0. Upper is 80, because we include 80. N is our number of trials, which is 200, right? There's 200 cars in this sample. And our P, can you guys see the P? Yep, cool. Our P is the probability that any given car weighs less than 1350, which in this case is 0.4. Now, I'm not getting that from this 0.4, I'm getting that from this. So this 0.4 and this 0.4 are completely separate. It just happens that this is the same, like it's the same number. Now, putting that in our CAS, what you'll get is the probability that x is less than or equal to 80 equals 0.5307, which means that therefore the probability that p hat is less than or equal to 0.4 equals 0.5307. Guys, this is our second and final mark for part E, and that actually wraps up MM441, guys. So congratulations on finishing the question. If you have any questions about it, as always, please let me know in the comments below and I'll get to it as soon as I possibly can. But otherwise, thank you very much for watching and I'll see you in the next video.